AP Cram, Calculus AB, Free Response Exam Review. Question 12, Relative Maximum. The figure shows the graph of f prime, the derivative of a twice differentiable function f, on the interval between -3 and 4. The graph of f prime has horizontal tangents at -1 and 1, and at x is equivalent to 3. The areas of the regions bounded by the x-axis and the graph of f prime on the intervals between -2 and 1 and 1 and 4 are 9 and 12 respectively. Find all x coordinates at which f has a relative maximum. Give a reason for your answer. I'll give you a moment to formulate your thoughts. All right, so in the effort to identify whether or not they are a relative maximum, one has to find the critical points. And critical points occur wherever f prime is equivalent to 0, okay? That's the first derivative, or d dx of the function is equivalent to 0. So f prime of x is equivalent to 0 at x is equivalent to -2, x is equivalent to 1, and x is equivalent to 4. Okay, so that's the first step. And then we have to apply the first derivative test, okay? And that is basically going to tell us whether or not we have a relative maximum. So in an application of the first derivative test, f prime changes from positive to negative at x is equivalent to -2. Therefore, at -2, we have a relative maximum, okay? Critical values where f prime of x is also equivalent to 0. Note, you can also have a critical value if f prime of x is undefined, but on this interval, we don't have any spots where f prime of x is undefined. Notice the f prime of x is goes from negative to negative, so we don't have like a relative maximum or anything. And this seems to be going from negative, and then it seems like it's going to be positive. So this could be like a relative minimum, because in order, if the derivative goes from negative to positive, that means it would have to take like a dive and then go up the actual function. All right, so that could be considered a local or relative minimum. All right, so that's not what we're looking for. The only answer that fits is this one right here, because going from something being negative, that means the function is climbing. If it becomes positive, having something going from being positive to negative means that, you get to the top of the hill and you go down, okay? Don't worry that it's positive and dropping, just worry that it's positive and then it becomes negative.